Given a collection of paired data samples, the regression line, which is the same as the line of best fit, what line fits the data the best, or the least squares line. The least squares line means that I'm finding the distance between my point and the line that I'm assuming it is, and I'm squaring it, which makes it positive. So now I add up a bunch of positive values, and whichever has the least value would be the line of best fit, which we would call the regression line. And it's the straight line that best fits the scatter plot of the data. The regression equation is here. The equation of a line in slope-intercept form would be y equals mx plus b, where m is the slope and b is the y-intercept. B is the y-intercept, which means where the graph hits the y-axis. We call this y hat because we're approximating. It's not an actual definite value. I'm taking y and making it y hat, and I'm changing the order of these two values. I'm going to put b first, plus mx. And this b refers to this b. This is the y-intercept. If I were to look on a graph, let's say we have a graph that looks like this. Let's say we have a graph that looks like this. This is my y-intercept, and b0 means exactly the same thing, where this line starts. And then b1 is our slope. It's exactly the equation of a line. We have this regression line, and we can create this. Let's go back to our Statcrunch. And let's go back and graph that one. Let's graph the scatter plot, shoe print, height, and we're going to overlay a polynomial of order 1. What that means is it's a line. Order 1 means 1 degree, x to the first power. And I believe that's really all I need to do. So let's compute. And we have a graph. That looks pretty close, right? If I hover over this line, notice I have an equation. Where does that equation come from? I think I might, okay. Should have kept them both. So here's my line with the numbers. And notice those are the same numbers as here's our intercept and here's our slope. There's our intercept and our slope. And they're saying that the height, which is our y, there's our y, is equal to that the 80.93 plus the 3.21 times, we said times x, they said times shoe print. Our shoe print is our x. If I open this up and I open this up, we have our parameters. There's my intercept. Remember we said y equals mx plus b. Y equals mx plus b, where m is the slope and b is the y-intercept. We're using y hat is equal to the slope. Well, here's the slope right here. 3.22. I'm just going to round it to 2 decimal places. Times x plus our intercept, 80.93. And if I want to put it into the form that they would like, it's 80.93 plus 3.22x. These are exactly the same. I just changed the order. And look at our p-value. Our p-value is tiny. what does a tiny p-value mean? And we only look at the p-value for the slope, and you can use this p-value. These p-values will match. So this is telling me I have a good estimate. The general form of the regression equation has a y-intercept of 80.9. They rounded it a little more than I did, and a slope of 3.22. Intercept, slope, notice, small p-value. Here, this is right here. And we can write the equation of the regression line as y hat equals 80.9 plus 3.22x. I do have one more problem though, so let's do that now. For a data set of weight in pounds and highway fuel consumption amounts of 10 types of automobiles, the linear correlation coefficient is found. They're not telling us what it is, but they are telling us the p-value is 0.012. And I want to put that in here as a percent. So I have to multiply by 100. Remember, when I went from a percent to a decimal, I started with a percent and I went to a decimal by moving my decimal place 2 places to the left or dividing by 100. So if I want to go from a decimal to a percent, I multiply by 100, which is really the same as moving this decimal point. This is times 10 times 100. This equals 1.2%, which is low. It's under 5%. When it's under 5%, there is sufficient evidence to conclude that there's a linear correlation between weight and highway fuel consumption in automobiles. If this was above 5%, it would be high. And let's check our answer. We did it. And that concludes this video of 2.4. This is it until next time. Thanks for watching.